In 2015, there was a huge excitement in the space community. That is because, up until then, the best image we had of the Pluto system was this. Hubble also squinted its lens at Pluto, but it is so small and distant, the best it could see was a few blobs of color variation. But in 2015, this all changed. That is because, after a 9-year journey, the New Horizons space probe flew by the dwarf planet, giving us a detail and fidelity of Pluto and its moons like we had never seen before. So the question is, what did the New Horizons probe see and discover during its flyby of the Pluto system? And what has it been doing since the flyby? I'm Alex McColgan and you're watching Astrum. Stick with me in this video and I will show you all the highlights from the New Horizons mission to the Pluto system and beyond. Let's first of all give you a quick bit of context in case you are new to Pluto or it's been a while since you last heard about it. Pluto is a remarkably pretty, tiny world, much smaller than our moon. It's found in the Kuiper belt, a dispersed belt of asteroid or comet type objects beyond the orbit of Neptune. Pluto was the last of the traditional 9 planets to be explored. This was due to its distance from us, but also because, can you believe this, it wasn't considered a very interesting celestial object. Thankfully, the team behind the probe pushed hard for this mission to be approved, and in 2006, New Horizons was launched as part of NASA's New Frontier program for medium-budget space missions. The goal of the mission was to get to Pluto as soon as possible, and as such, New Horizons was the fastest launch ever, it being a light spacecraft on the most powerful rocket available at the time, a fully boosted Atlas V. It whizzed past the moon in only 9 hours. The Apollo missions took 10 times as long. On its way to Pluto, it used Jupiter as a gravity assist, which shaved 3 years off the arrival time. It also used Jupiter as a trial run for its systems, taking some remarkable videos and images of the planet and its moons. After this successful trial, New Horizons went into hibernation mode to prevent the wear and tear of its instruments. Leading up to its approach in 2015, the team turned the systems back online, and every day the spacecraft sent back images of the Pluto system. This was an incredibly exciting time for enthusiasts following the story. We began to get hints of what Pluto could possibly look like, and saw how different Pluto was from its biggest moon, Charon. Every day the resolution got higher and higher, and more details could be made out. Yes, there were other scientific goals for the mission, but the most interesting thing to me was what it looked like. Soon there could be seen what looked to be a heart shape on the dwarf planet. On the 14th of July, the New Horizons probe made its closest approach, at only 12,500 kilometers from the surface of Pluto. However, mission controllers didn't get a look straight away. Firstly, the probe was too busy taking a lot of photos during the flyby to send anything back immediately. Once data transfer commenced, they had to deal with the slow uplink speed of only 1 kilobit per second. Further to that, there was a 4.5-hour latency between the spacecraft and the Earth. But what it saw and sent back was spectacular. Mountain ranges, ice plains, glaciers, and an atmosphere. It also had a good look at some of Pluto's moons. Let's go into detail about what it actually discovered during this flyby. One of the first things observed about Pluto is its unusual relationship with its moons. For a start, Pluto's biggest moon, Charon, orbits very closely to Pluto and is also very big in comparison. This means that the barycenter of the two objects, or in other words, their center of mass, is outside the primary object. They actually both orbit around a point in space. Not only that, but both objects are tidally locked to each other. This means that if you stand on one, the other won't move from that point in the sky. This is very unusual because while some moons are tidally locked to their parent planet, the planet is not also tidally locked to the moon. Charon is very different visually from Pluto, being much darker. This implies they are not from the same origin. The rest of Pluto's moons are very small, only a few kilometers across. Their orbits are exceptionally circular and are all coplanar with Pluto's orbit. The geology of Pluto is very interesting. The biggest visible feature on Pluto is this giant heart shape, which wowed the world when it first came into view. It has since been named Sputnik Planitia. It is the size of Texas, and it has a strong color contrast to the surrounding area. This is because it is a giant ice plain. In fact, during the flyby, it was confirmed that 98% of Pluto's surface is composed of nitrogen ice. On average, the temperature on the surface of Pluto is minus 229 degrees Celsius, which means water ice would be rigid and brittle. On the other hand, nitrogen ices at this temperature act like water ice on Earth, meaning it can flow as glaciers. This can especially be seen around the edge of the heart, glaciers flowing into the gaps around the craters and mountain ranges. The ice plains themselves have giant polygon shapes across the entire area. There are also no craters, which means it must be a relatively new feature, or a feature that is being continually renewed. It is perhaps only 10 million years old. The polygonal cells show ridges on them which are likely caused by sublimation, the process of an ice turning directly into a gas. Ices sublimate and freeze here regularly, creating troughs and pits, meaning these polygons are likely to be convection cells. These cells are moving and can be seen pouring into the mountain ranges surrounding the region through slow-moving glaciers. Sputnik Planitia could be compared to Greenland and Antarctica, in that it controls the climate of Pluto heavily. Although it is not known for certain, Sputnik Planitia could have formed from an impact, and ices filled the crater in from a potential subsurface liquid ocean. This filled-in basin actually causes a positive gravitational anomaly. A gravitational anomaly is where the gravity at one point is different from elsewhere on the object. The ice plane is directly facing away from Charon, which would align it up with the object's tidal axis. Due to the short distance between Pluto and Charon, tidal effects are very strong on both objects. This could be the reason why Pluto is tidally locked to Charon, and the two objects can't look away from each other. Surrounding the ice plains are vast mountain ranges made of water ice, which, when viewed from the side on, look spectacular. Water ice is the only type of ice detected on Pluto that would be strong enough to support heights of several kilometers at this temperature. Among the mountains found on Pluto, there might also be some which are cryovolcanoes, some of the most likely candidates being Wright Mons. It is 4 kilometers tall, one of the highest peaks on Pluto, and a big depression is found in the center. Cryovolcanoes could be a contributing factor for Pluto's young surface. Here is an extremely interesting region called Tartarus Dorsa. It is an extensive, highly distinct set of 500-meter high mountains that resemble snakeskin or tree bark. They are thought to be penitentes. If that is true, Pluto is the only place in the solar system other than Earth where they have been observed. Even on Earth, they are very rare, but some can be found in the Atacama Desert and other dry, high-altitude regions. The ones on Pluto are much taller and cover a much vaster area than on Earth. We can only imagine what they look like up close. Another obvious feature of Pluto is the dark material that seems to be sprinkled on the surface in some areas. The biggest such area is called Cthulhu Macula. It is weirdly reminiscent of a whale in shape, as can be seen in this image. The region on Pluto is much more heavily cratered than the heart, which implies the surface there is much older. Mountain ranges can be seen in the middle of Cthulhu Macula, topped with what is thought to be methane ices. Methane apparently condenses as frost at higher altitudes on Pluto. The dark color is thought to be a deposit of tholins, a kind of tar made up of hydrocarbons that have interacted with sunlight. Similar deposits can be seen on one of Saturn's moons, Iapetus, so the process has been seen elsewhere in the solar system. Scientists suspected this substance was tholins as soon as New Horizons started sending images back, but its distribution over Pluto's surface was baffling. Why are only some areas covered? Also, how dynamic are the processes surrounding the distribution of tholins? Has Pluto looked like this for a while, or is this a changing environment? It turns out that these tholins may well be connected to cryovolcanism found on Pluto. Pluto is one of the few objects in our solar system where cryovolcanoes are actively shaping its surface. Water from either the mantle or from pockets of water trapped in the crust erupt over the surface of Pluto, creating a varied landscape. But it turns out that it's not just water found in these eruptions, but tholins are clearly mixed in too. Data from Hubble suggested that Pluto was getting redder, and new horizons may have passed by during Pluto's reddest time of its year. And new horizons may have found out why. Here, in a region called Viking Terra, we see a cryovolcano that has fountained this water tholin slurry across the immediate surroundings. Just next to this region, we see a crater and trough filled by this slurry during another eruption. By the trough, you can see where this slurry flowed down and pooled. This can also be seen in another region by Virgil Fossae, another trough where this slurry has travelled down. However, the most interesting thing about tholins is not found on Pluto itself, but rather on its twin dwarf planet, Charon. In this enhanced colour image of Charon, what do you immediately notice? The red cap over its north pole. Incredibly, because Pluto's gravity is so weak, when it erupts this slurry mixture, some of it escapes Pluto altogether and makes the 19,000 kilometer journey to Charon. The tholins are localized here because Pluto and Charon are tidally locked to each other. They only ever show each other one face. Poetically speaking, Pluto is always hiding its heart from Charon in this eternal waltz. This means that more tholins fall on a specific spot on Charon rather than all over. And speaking of Charon, some interesting discoveries have been made about it too. It is a water ice world, unlike Pluto, whose surface is predominantly nitrogen ice. As such, it doesn't really have an atmosphere like Pluto does, as the water ice is locked to the surface. On Pluto, the nitrogen ice sublimates depending on Pluto's seasons, meaning Pluto's atmospheric density can vary by many orders of magnitude over the course of its year. With this sublimating and refreezing of the atmosphere, Pluto's appearance may change dramatically over the course of its 248-year-long seasonal cycle. For me, the most impressive discovery that New Horizons was able to confirm was that Pluto has an atmosphere. And not only that, but the images are incredible. Due to Pluto's small size and weak gravity, the atmosphere appears to extend high above the surface of Pluto. Earth's atmosphere, while being much more massive and dense compared to Pluto, hugs the planet comparatively tightly as the gravity is a lot stronger. The atmospheric pressure on Pluto, on the other hand, is exceptionally low, roughly 10 microbars, or 100,000 to 1 million times weaker than the surface pressure on Earth. It is theorized that the pressure could increase to as much as 18 to 280 millibars, 3 times the surface pressure on Mars and a quarter of the surface pressure on Earth. This may happen throughout Pluto's year. At some points in its orbit, it is closer to the Sun than Neptune. This would make the temperature rise, causing the surface ices to sublimate into gases, the process of which there is evidence of in the ice plains. But the last time Pluto was thought to have an atmospheric density similar to Mars was 900,000 years ago. At this pressure and temperature, the conditions could be right for liquid nitrogen to form on Pluto's surface. Some evidence of this might be found here, in what appears to be a frozen lake. At any rate, within just 1 year, Pluto's atmospheric density can vary by a factor of 4 due to seasonal variations. That is a massive contrast compared to other solar system objects with atmospheres, which generally stay pretty consistent. The atmosphere consists of the same ices found condensed on the surface, namely nitrogen, methane, and carbon dioxide. The other fascinating discovery New Horizons made about the atmosphere is that it has up to 20 haze layers. Haze layers themselves were not unexpected, but the amount of them was. They can clearly be seen in some of these images, acting like layers of a thin kind of fog. Sunlight can be seen streaming through one such layer in this photo, the shadows from the mountains clearly seen in contrast to the sunlight shining through the haze. The layers do not appear to be level across the planet. Here you can see this haze layer high above the surface, but on this side of the image it touches the surface. On a side note, to me these are the most breathtaking photos of Pluto, and I purposefully saved them until last. You can truly appreciate depth and the scale of the mountain ranges, Pluto almost seeming like a toy replica due to the extreme topographical relief. But these mountains appear so high because Pluto is so small and its gravity is not strong enough to pull them down. In June 2020, scientists released a paper stating that under Pluto's surface is believed to be an ocean of liquid water, very much like the icy moons of the gas planets. It was originally thought that Pluto formed cold, being so far away from the Sun. However, evidence from New Horizons suggests that this is not the case, but rather it started off hot. This means it's always had an ocean, and if that is true, then there is a case that habitability on Pluto may be just as good as habitability on the closer icy moons. In fact, if Pluto is the standard for dwarf planets found in the Kuiper Belt generally, there may be many more habitable worlds out there. How do we know it had a hot start? There is evidence of expansion, not contraction, on its surface. These cracks show the crust is moving apart, not folding over itself. If this is true, and Pluto had a hot start, perhaps with bombardments from other planetesimals heating it up during the early stages of the solar system, it could be that shortly after it was formed, it would have had enough thermal energy that it was once an ocean world. This really puts a new perspective on how the solar system formed. While the absence of craters is limited to Sputnik Planitia, it is amazing how few craters there are on Pluto and Charon generally. This might not just be because their surfaces are young, but perhaps the Kuiper Belt is more devoid of smaller objects than we may have first thought. The flyby was over in a matter of days, and New Horizons started heading deep into the Kuiper Belt. New Horizons had travelled so far from Earth at this point that when it looked at our closest star system, Alpha Centauri, it was clearly in a different place from New Horizons' perspective than from ours. This is due to the parallax effect, something I've done a video about here if you want to see some more astronomical examples. It's just mind-boggling to me to think about how far New Horizons has travelled relative to us, so much so that Alpha Centauri has moved from New Horizons' perspective. Conversely, however, New Horizons has travelled all that way, and that's the only difference it's made to the view of our closest neighbour. Space is just so big. When New Horizons made its flyby of Pluto back in 2015, it barely slowed down at all. Its trajectory after the encounter actually took it further into the Kuiper Belt. Given that this region is so far from Earth, it is largely uncharted territory, a place where no man has gone before. So, did the New Horizons team know of an object that they could visit next? Yes, they did, and its name is Arakoth. But incredibly, they didn't even know of its existence before New Horizons was launched. So, what is Arakoth? What does it look like? And what makes it unlike anything we've ever seen before? You see, the year previous to the Pluto flyby, time had been given to the New Horizons team with the Hubble Space Telescope so that they could locate an object for New Horizons to visit after Pluto. Hubble actually discovered 3 new objects reasonably close to where New Horizons would be going, and after studying the data, the 35-kilometer long object now known as Arakoth was chosen. As a result, Arakoth would be the first object visited that was discovered after the spacecraft visiting it was launched. New Horizons was healthy and well after the Pluto flyby, with propellant left in its tank and years left in its RTG, and so commands were quickly sent to New Horizons by the mission team to adjust its course so that it could rendezvous with a promising new target. Being so small and far away, we didn't know much about the object. All Hubble could detect was its color and the dips and peaks in its brightness as it rotated. However, scientists also observed Arakoth's occultation of a star. Incredibly, from this occultation, they were able to predict the shape of Arakoth, and as you will see later, this prediction was almost exactly right. At the very least, they knew it would be an elongated object, so potentially a contact binary, or simply a long asteroid-type object. It was up to New Horizons to confirm their predictions. 3 years after leaving Pluto, in August of 2018, New Horizons began its approach phase at a distance of 172 million kilometers. At this distance, Arakoth was barely visible to New Horizons against the backdrop of distant stars. But by December 2018, it was bright in New Horizons' view. Traveling at 51,000 kilometers an hour, New Horizons was rapidly gaining on Arakoth, and science data at this point was already beginning to be collected. As New Horizons got closer and closer, Arakoth's shape could start to be resolved. It was bizarre looking, what appeared to be a contact binary, and was relatively crater-free with a lumpy surface. It was unlike any of the asteroids or comets we had ever seen up close before. On the 1st of January 2019, New Horizons made its closest approach at a distance of only 3,500 kilometers from its surface, and it was on this day that it captured most of its science data. This flyby made Arakoth the most distant object ever visited by a spacecraft, being 6.5 billion kilometers from the Sun at the time, or roughly 45 times further away than the Earth is from the Sun. Being this far away, the data speed was abysmally slow between Earth and New Horizons at only 1 kilobit per second, although I will mention that it's incredible to me that the technology was there for them to communicate with New Horizons at all. This slow data transfer speed has meant that it's taken around 2 years to send all of the data it collected around Arakoth back to Earth. The highest priority data was sent back first, namely the images, although I do remember at the time that the highest resolution images took a while to arrive back. Only low resolution images were available when all the media outlets were publishing stories of the flyby, meaning I would guess that most of the general public never saw Arakoth in all of its glory. So, here it is, the highest resolutions we have of this fascinating object in true color. What you'll immediately notice about Arakoth is that it is reddish in color, unlike most asteroids nearer to home, which are grayer and darker. It's red because of a similarity it shares with Pluto. It has an abundance of tholins on its surface. Tholins are organic compounds that have been broken down by solar and cosmic rays. Organic compounds on the surface probably included methane and ammonia at one point. However, Arakoth does not have any of these substances left, probably due to its low mass. What Arakoth's spectra does reveal is that it has methanol, hydrogen cyanide, and water ice on the surface. This abundance of methanol on Arakoth's surface is the main factor behind its red color, as irradiated methanol is likely the cause of the tholins. However, there is a bit of a mystery in Arakoth's spectra, as interestingly, there is also an absorption band at 1.8 micrometers in Arakoth's spectra, and scientists do not know what this compound is. It is yet to be identified. It's nothing we've seen before. It's a shame we weren't able to get a sample of its surface to be able to say for sure. The next thing you'll notice about Arakoth, compared to asteroids closer to home, is the absence of small impact craters. It is believed that this is due to the nature of the Kuiper belt itself. It could have 20 to 200 times the mass of our asteroid belt, but a lot of this mass is also contained within large Pluto-like bodies which dot the belt. While we can't say for sure what the population of the Kuiper belt is, it is definitely more spread out than our asteroid belt, simply because it's 20 times as wide and has a much bigger circumference. Being this far from the Sun means orbital speeds are much slower, so even if an impact does occur, it will be at a low velocity. Meteorites you see creating shooting stars in the Earth's atmosphere may hit us at around 75 kilometers a second, whereas impacts in the Kuiper belt may only be at speeds of 300 meters per second. This depression here, which looks like a crater, may not actually have been formed from a collision, but it could be a sinkhole caused by the escape of volatile substances just under the surface. The lack of collisions means that what we see of Arakoth now is like a time capsule from the early solar system, an object that has been preserved for billions of years. Although, a slow collision is one of the ways this object may have come into being. When asteroids in the asteroid belt impact each other at high speeds, they either cause craters or cause the body to completely fragment. But a slow collision, like those in the Kuiper belt, may cause both objects to simply merge. It may also be that the two lobes of Arakoth formed side by side in a swirling cloud of ice fragments that coalesced into two orbiting bodies. Eventually, these bodies got closer and closer until they joined together. In any case, the merging would have happened very slowly because there weren't many fractures or stress lines to speak of, so the maximum speed of the collision would be no more than 2 meters a second. Plus, the two objects would have also had to have been tidally locked to each other before merging too. The fact that both lobes of Arakoth look very similar gives weight to the theory that they formed in the same region. Before Arakoth got its formal designation, you may have known it by a different name. It was originally nicknamed Ultima Thule. Now, the individual lobes are known as Ultima and Thule. You'll also notice some very bright regions on the surface. The ones in the crater are probably from avalanches as material fell inward after the sinkhole appeared. The other major bright patch is found around the connecting point between the two lobes. It's not known with certainty why this region is brighter, but theory suggests that this region sees the least amount of sunlight, so perhaps volatile substances can build up here, like ammonia ice. It could also be that because this region would be the center of gravity of the object, loose material rolls down the lobes to collect in the center. With a density of only 0.5 grams per centimeter cubed, Arakoth is not going to be densely packed, but it is probably porous. Volatile materials would have escaped the interior of the object over time due to an internal heat source, but then these materials would freeze on the surface, leaving behind only rocky remains inside. This heat source can still be detected to some degree, as models suggest that Arakoth should only be 12 to 14 Kelvin. However, New Horizons found that it was in fact 29 Kelvin. That is still extremely cold, just not quite as cold as we were expecting. There's one last mysterious characteristic of Arakoth that isn't immediately apparent from these images, that only got discovered after trawling through the New Horizons data. And that is that Arakoth is in fact much flatter than we would have expected. We didn't notice it at first because Arakoth rotates like this, meaning we didn't see too much of it lit up from a side angle. We don't really know why it's flat. Maybe it was due to centrifugal forces when the individual lobes formed, implying it was spinning a lot faster than it is today. Or maybe it's due to the way Arakoth orbits and rotates, meaning one side of the object is constantly exposed to the sun for decades at a time. This would cause volatile substances to escape only on one side, until later in the year when the other side is exposed to the sun. Research is still underway to model the cause. As New Horizons left Arakoth, it looked back and caught one last glimpse of its silhouette against the backdrop of stars. Who knows if Arakoth will ever be visited again, so it may well be that this is the last close-up view that we will ever have. What's next for New Horizons? Well, it still has life in its battery and 11 kilograms of fuel still on board, so the hunt is now underway to search for any additional targets. Beyond that, it will follow the path of the Voyagers, passing through the heliosphere of the solar system in the 2030s. Even if no other Kuiper Belt object can be discovered close enough to its current trajectory that it can do a third flyby, the New Horizons team is already submitting proposals for an extended mission that will have a completely different focus. They want to convert New Horizons into a highly productive observatory, conducting planetary science, astrophysics, and heliospheric observations that no other spacecraft can, simply because New Horizons is the only spacecraft in the Kuiper Belt and the Sun's outer heliosphere, and far enough away to perform some unique kinds of astrophysics. Those studies would range from unique new astronomical observations of Uranus, Neptune, and dwarf planets, to searches for free-floating black holes and the local interstellar medium, along with new observations of the faint optical and ultraviolet light of extragalactic space. Beyond that, New Horizons has already given us a wealth of data on Kuiper Belt objects that we would not have known about otherwise. Who knew that this is what Pluto would look like? That Charon has a red cap? That Arakoth would be flat? And considering these are the only Kuiper Belt objects we've ever seen up close, there's bound to be a lot more out there that's still waiting to surprise us. Thanks for watching. If you like this New Horizons video, you should check out some of the other spacecraft videos I've made here for more of the same. Thanks to my patrons and members for supporting the channel too. If you want to help me make more videos and have your name added to this list, check the links in the description below. All the best and see you next time.